Massive stone walls stand in remote jungles, fitted together so perfectly that not even a sliver of light passes between them. This impossible precision is an ancient mystery that completely reshapes our view of history. By the end of our journey, you will understand the hidden tools and forgotten methods that built these marvels. We will explore why some stones appear to have been softened like clay, and how blocks weighing more than 100 tons were moved across impossible terrain. What does true human ingenuity look like when it leaves no easy answers behind? That profound sense of wonder is not just a feeling, it is a doorway into a deeper mystery. When you stand before a wall of stone blocks fitted together without a trace of mortar, your mind instinctively searches for a point of reference. You might think of the most precise modern machinery, the laser cutters and diamond saws that can achieve such a clean fit. Yet here is that same perfection, carved from granite and andesite, achieved in an age we are told relied on simpler tools. This cognitive dissonance is the very heart of the allure. We are not just looking at old buildings, we are confronting a silent challenge left by the past. These structures, set in remote jungles and perched on mountaintops, were deliberately placed far from the easy paths of later civilizations. Their isolation protects their secrets, ensuring that the methods of their creation were not diluted or lost through common trade or conquest. For centuries, this has drawn in explorers who braved treacherous terrain, not in search of gold, but in pursuit of an answer. It captivates engineers who run complex calculations only to find that conventional explanations fall short. The question, how did they do it, echoes far beyond archaeology. It strikes at our fundamental understanding of human innovation and the untold chapters of our own history. To feel that mystery is to begin the journey of unraveling it. The term perfectly fused sounds like something from a science fiction novel, yet it is the only phrase that fits what we find. This is not about stones that are merely stacked with impressive skill. What we are investigating are blocks that seem to have lost their individual boundaries, merging into a single, unshakable mass. The joints are so tight and complex, often interlocking in 3 dimensions, that they have become geological puzzles. Think of trying to fit 2 irregular pieces of a broken ceramic plate back together. No matter how carefully you align them, a hairline crack remains. Now imagine doing that with 2 chunks of granite, each weighing 20 tons, and achieving a seam so flawless that it cannot be penetrated by the thinnest blade. This is the reality of the walls we are studying. The surfaces where these colossal blocks meet frequently show strange characteristics. The stone itself appears to have been altered, as if it was briefly brought to a plastic, malleable state before being pressed against its neighbor. This created a bond that is more than just mechanical. It has proven resilient against the immense forces of nature, from violent earthquakes that topple modern constructions to centuries of relentless wind and rain. This evidence points toward a forgotten science, a deep and intuitive knowledge of stone itself. Conventional history often describes these achievements with simple terms like hammer stones and copper chisels. But the reality we see in the stone tells a far more complex story. To solve this ancient mystery, we must first learn to see the stones not just as building materials, but as messages from the past waiting to be read. These ancient walls speak a global language of impossible precision. This architectural mystery is not confined to a single jungle or mountain range. It is a pattern repeating itself across the world, from the high Andes of Peru to the sprawling temples of Southeast Asia. In Peru, the Sacsayhuamán fortress presents a formidable puzzle with its zigzagging ramparts. Here, colossal stones, some weighing more than 100 tons, are locked together in a complex three-dimensional jigsaw. The curves and angles of each block are so perfectly matched that the entire structure has withstood centuries of powerful earthquakes that would reduce modern buildings to rubble. Then, thousands of miles away, the temples of Angkor Wat in Cambodia rise from the jungle. The massive laterite blocks that form their cores are fitted with a jointless perfection that similarly defies simple explanation. The same signature appears on the remote shores of Easter Island, where the Ahu platforms are built with an engineering mastery that seems at odds with the island's isolation. In Japan, the submerged Ishi no Hoden stone, a massive and intricately shaped block, stands as another silent monument to this lost craft. Even certain older Egyptian structures, predating the more famous pyramids, display these characteristic polygonal fittings. When you map these sites, a profound question emerges. How could cultures separated by vast oceans and impassable mountain ranges, societies that history tells us never met, all arrive at the same breathtaking level of stonemasonry? The sheer geographical spread presents two fascinating possibilities. The first is that human ingenuity, when faced with the universal challenges of constructing lasting monuments, independently converged on an identical, highly advanced solution. The second, and perhaps more intriguing, possibility is that this was not invented multiple times, but was instead a shared knowledge, a common technological thread that somehow connected these distant corners of the ancient world. This global pattern elevates the mystery from a collection of local curiosities to a truly world-spanning enigma. Mainstream archaeology presents a world where immense patience and simple tools conquered stone. The dominant narrative describes teams of skilled workers using stone hammers to pound granite into submission, or patiently grinding away with abrasive sands and water to slowly carve a precise edge. Bronze chisels, though softer than the rock they were shaping, could theoretically work through relentless, repeated strikes. The fitting process is often portrayed as a monumental exercise in trial and error. A massive block would be painstakingly maneuvered into place. A mason would check for high spots, and then the block would be lifted again for more hammering and grinding. This cycle would repeat over and over until the fit was deemed acceptable. For moving these titans, the explanations rely on a clever application of basic physics. Wooden rollers, earthen ramps, and vast numbers of people pulling on ropes become the engines of construction. It is a compelling image of pure human determination, a testament to what can be achieved with enough time and coordinated labor. And for many ancient structures, these explanations provide a satisfactory, logical framework. Yet when we hold this conventional toolkit up to the light of the most anomalous sites, we begin to see significant gaps. How does a process of repeated test fittings account for seams that are complexly curved in 3 dimensions and fit with a precision measured in fractions of a millimeter? How does pounding with another rock explain stone surfaces that appear to have flowed and fused together, showing microscopic signs of having been in a softened state? The sheer scale and perfection presented at places like Sacsayhuamán suggest that trial and error on 100-ton blocks would have been an almost impossibly slow and unstable process. This is not to dismiss the incredible skill of ancient artisans, but to acknowledge that the standard model, while logical, may be incomplete. It attempts to solve a master-level puzzle with only the most basic pieces from the box, leaving us to wonder what advanced techniques have been lost to time. The gap between a good fit and a perfect fusion is a vast chasm of time and effort. Think for a moment about the sheer physical process of shaping granite with another piece of rock. Each impact from a stone hammer does not neatly slice the stone, it crushes and pulverizes a tiny amount of the surface. To achieve a flat plane, a mason would have to constantly check for high spots and methodically pound them down. Now magnify that challenge to a block weighing 20 tons, with a surface that is not flat but a complex, undulating curve that must lock perfectly into its neighbor's equally complex form. The trial and error process becomes almost unimaginable. Lifting a stone of that mass even a single inch is a monumental task in itself. Doing it dozens or even hundreds of times to shave off minuscule imperfections would turn a single wall into a project spanning generations. Yet at many of these remote sites, the archaeological evidence does not point to centuries of continuous, slow labor. Instead, the construction phases appear concentrated, as if these monumental projects were completed with a decisive speed that defies the traditional narrative of endless pounding. This speed is the first major crack in the conventional explanation. The second is the very nature of the joints. A simple, flat seam can be achieved with patience and a long, straight abrasive stone. But the walls we see are masterpieces of three-dimensional geometry. They feature blocks with multiple protruding angles and corresponding recesses that lock together from the front, the side, and even from below. Creating this with pounding tools would be like trying to carve a perfect, multi-faceted key entirely by smashing it with a hammer. The precision required is simply not a strength of impact-based tools. This leaves us with a compelling dilemma. Either ancient societies possessed levels of patience and coordination so extreme that they redefined what is humanly possible, or their technological toolkit contained something we have yet to fully recognize, a method that allowed them to work with stone in a way that was both swift and supremely accurate. The stone itself seems to tell a different story, one written not with hammers but with heat. At the heart of this mystery lies a startling physical clue, a detail so subtle you could easily walk right past it, yet so profound it challenges everything. Look closely at the granite blocks of Ollantaytambo in Peru. On certain surfaces, the hard, crystalline rock does not appear to have been cut, but rather shaped. It displays gentle, undulating swirls and rounded, blunted edges, as if the material was once as pliable as thick clay. In other places, two massive stones meet with such intricate, flowing conformity that they look less like fitted puzzle pieces and more like two lumps of soft wax pressed together and left to harden into a single, unbreakable form. This is especially clear where a block must wrap perfectly around a corner or fill an awkward, irregular space. You do not achieve that kind of seamless, organic fusion by pounding with another rock. The stone itself bears the marks of having been in a temporary, malleable state. The implications of this are staggering. It suggests that the builders did not just carve the stone, they commanded it. They possessed a method, a technology perhaps, to alter the very physical state of granite and andesite, materials we consider unmovable and permanent. This was not brute force, it was a form of high craftsmanship that borders on alchemy. How could anyone achieve such a thing? The concept feels almost like magic, yet the evidence is right there, frozen in the rock for centuries. If these stones were indeed softened, then the entire narrative of ancient construction collapses and is reborn. We are no longer looking at a story of immense labor, but one of lost knowledge, a forgotten science that understood the hidden properties of matter itself. The challenge of construction pales before the mystery of transportation. How do you move a block of stone heavier than a fully loaded semi-truck across 60 miles of some of the most unforgiving terrain on Earth? At the high-altitude site of Pumapunku in Bolivia, the builders worked with andesite, a volcanic rock as hard as granite. The quarries for this stone lay far across a landscape of steep mountains and deep valleys. The journey for a single 130-ton block would have been an epic undertaking in itself, a slow-motion trek through impossible geography. The conventional image of hundreds of workers straining on ropes, guiding the colossal stone on a path of rolling logs, feels almost too simple, too fragile for such a monumental task. Logs can splinter under such immense, concentrated weight. Earthen ramps would need to be impossibly long and stable to navigate significant changes in elevation. And every single bump, every slight tilt, risked cracking the precious cargo, undoing years of quarrying labor in an instant. This was not merely a hauling job. It was a high-stakes logistical ballet performed with stones that had to arrive in pristine condition, ready for their perfect final fusion. The sheer distance and difficulty force us to ask if we are missing a fundamental piece of this ancient puzzle. Could sound or vibration have been used to somehow reduce friction, making the stones glide across the ground? Might there have been a forgotten application of plant-based substances that temporarily altered the surface of the stone or the earth beneath it, creating a slick pathway? The Transportation Conundrum pushes us to look beyond ropes and ramps, to consider a form of applied physics that turned an impossible journey into a manageable, repeatable process. This is not about finding a simpler answer, but about discovering a smarter one, a lost chapter in humanity's long conversation with the material world. The true marvel lies not in the stone blocks themselves, but in the negative space between them. Walk up to the walls of Coricancha in Cusco and run a hand over the joints. You will not feel a seam, a crack, or even the slightest irregularity. Your eyes tell you there are multiple stones, but your senses report a single, continuous sheet of rock. This perfection is not reserved for simple, flat walls. The most baffling sections are built from a chaotic jumble of polygonal blocks, each with a unique shape boasting a dozen different angles and curves. Yet every single one of these irregular giants locks into its neighbors with the same breathtaking precision. How could such random-looking shapes achieve such uniform, flawless contact? The answer points away from random artistry and toward a repeatable, systematic technology. This was not a matter of a single master craftsman achieving a one-time miracle. This was a standardized process applied to thousands of individual stones, ensuring that every single one, regardless of its complex geometry, would snap into place as if it were part of a preordained whole. The consistency is the real clue here, a signature of a method that was taught, learned, and replicated. Even more curiously, the fit is often microscopically tighter at the base of these walls than at the top. This subtle detail opens up a fascinating line of inquiry. Did the builders anticipate the structure's settlement over centuries, engineering the initial fit to become perfect under the immense weight of the stones themselves? Or does this tell us something crucial about their construction process? Perhaps that the stones were set from the top down, or that the final act of joining them involved a force that was applied from below. This is not the kind of imperfection you get from hand carving. It is the hallmark of a deeply sophisticated understanding of physics and material behavior, a planned outcome written in stone. This final polished surface is the master's signature, a flawless finish that defies simple tools. While ancient quarries are littered with the evidence of labor, with rough-hewn blocks showing the scars of stone hammers and primitive wedges, the finished walls tell a completely different story. They are silent, smooth, and almost sterile. The chaotic noise of the quarry has been replaced by a profound and unsettling quiet in the stone. How do you take a block of granite, one of the hardest stones on the planet, and transform its face from a rough, pitted texture into a surface as smooth as glass, without leaving a single trace of how you did it? This is the fourth great mystery, the absence of the artist's hand. If they were using the tools we give them credit for, bronze chisels and stone hammers, then the finished wall should be a museum of their efforts. We should see the faint, overlapping arcs of countless hammer strikes, the shallow grooves from abrasive sands, the occasional slip of a chisel. Yet on the most precise andesite blocks at Pumapunku or the granite marvels of Egypt, these marks are simply not there. It is as if the final stage of construction involved not more work, but a form of erasure. This presents us with two fascinating possibilities. The first is that these cultures developed a finishing process so effective, so thorough, that it completely eliminated all evidence of the preliminary work. This would be like sanding a piece of wood so perfectly that you could no longer tell it was ever once a tree. The second, and more radical, idea is that the techniques used to achieve the final fit and finish were so fundamentally different from cutting and pounding that they never created tool marks in the first place. Perhaps the stone was shaped in its final position through a process that softened and reformed its surface, a method that left no scars because it never relied on impact. This missing evidence is itself a powerful clue, pointing away from the tools we expect and toward a forgotten art of working with stone, not against it. These chaotic, zigzagging walls are not the result of random chance. They are masterclasses in seismic survival. A straight wall made of rectangular blocks is rigid, a single, unyielding plane. When an earthquake's powerful waves hit it, that wall has no choice but to absorb the full force, often leading it to crack and topple. But look at the design of Sacsayhuamán. Each polygonal stone, with its dozen unique angles and facets, is an individual component in a massive, three-dimensional shock absorption system. When the ground begins to shake, these irregular blocks cannot slide past each other in a uniform way. Instead, they transfer and dissipate the energy through a complex web of interlocking points. The force is channeled, divided, and redirected, spreading out across the entire structure rather than concentrating on a single, fatal weak point. It is architecture that dances with the earthquake instead of standing rigidly against it. This reveals an understanding of dynamic forces that seems centuries ahead of its time. The true puzzle is not just the engineering principle, which we can understand today, but the execution. How do you design a wall where every one of hundreds of giant stones has a unique, custom shape, and yet all of them fit together without a single miscalculation? This goes far beyond a skilled mason eyeballing a fit. It implies a planning stage of immense sophistication. Without paper, without complex drafting tools, how did they model this chaotic perfection? Did they use scaled clay models, or did they possess a system of geometry and mathematics advanced enough to calculate the distribution of stress and the necessary angles for every single block? The stones themselves are the blueprint, and we are still learning how to read it. This level of structural foresight points to a civilization that did not just build monuments, they built for eternity, with a wisdom that still whispers from the stones. This consistent precision across entire cities is perhaps the most humbling aspect of the mystery. At the sprawling metropolis of Teotihuacan in Mexico, the Pyramid of the Sun is a colossal undertaking in itself. Yet the same flawless stonework, the same exacting angles and seamless joints, appear in the Temple of the Feathered Serpent and in the sprawling residential compounds that surround the main ceremonial center. This was not the work of a single, brilliant architect whose secrets died with him. This was a city-wide standard maintained for hundreds of years, through the reigns of multiple rulers and across countless generations of artisans. The same phenomenon unfolds across the vast temple complex of Angkor Wat in Cambodia. From the central towers to the most remote library buildings, the same incredible joinery is present, a silent testament to a quality control system that spanned centuries. How do you preserve a secret that precise for that long? This level of consistency shatters the idea of a lone genius. It points instead to a robust and organized system, a veritable academy of advanced stonemasonry. There must have been master builders, teachers who passed down not just the skills, but the underlying principles of the craft. They would have needed a way to communicate complex three-dimensional geometries and stress distributions to their apprentices. Without surviving blueprints or detailed manuals, we are left to wonder about the form of this instruction. Were there precise clay models that have since crumbled to dust? Did they use intricate knot systems in cords or diagrams drawn on perishable animal skins? The knowledge was clearly too valuable and too complex to be left to chance or verbal tradition alone. This was a civilization's core technology, protected and transmitted with the utmost care. The stones themselves are the final exam, proving that every graduate of this lost school had achieved the same impossible mastery. Beyond the precision of their stonework, these ancient sites whisper of a deeper connection to the cosmos itself. At Machu Picchu, the Intihuatana stone is far more than a ritual object. Its carved angles and precisely positioned planes function as a sophisticated astronomical instrument. On the equinoxes, the sun casts no shadow from its central gnomon, a moment of perfect celestial balance that the builders could predict and mark with stunning accuracy. This was not a vague observance of the seasons, it was a measurable science carved in granite. The same profound alignment is found across the globe. Certain walls at the Calisasaya temple in Bolivia are oriented to capture the first rays of the winter solstice sunrise, painting a specific stone with light for only a few days each year. In Egypt, the Great Pyramid is aligned to the cardinal directions with a deviation of less than 1/15 of a single degree, an orientation that would have required a breathtakingly precise understanding of the Earth's rotation and the positions of the stars. These are not random occurrences, they are deliberate, repeated patterns that reveal a primary purpose for these structures. They were not merely temples or fortresses, they were grand observatories, calendars, and models of the universe itself. The stones were laid not just to endure time, but to track it, to lock the rhythms of the heavens into the unshakable foundation of the earth. This celestial knowledge forces us to reconsider the entire identity of these builders. They were not just master masons, they were astronomers and engineers who saw the sky and the earth as two parts of a single, interconnected system. This leads to an even more profound layer of integration. The builders did not just look to the sky, they listened to the land. Many of these sites incorporate natural geological features as if they were preordained parts of the design. At the Temple of Khao Phraya Vihan on the border of Thailand and Cambodia, the entire structure follows the natural contours of a dramatic cliff face. Its causeways and sanctuaries are not imposed upon the mountain, but rather emerge from it, blending man-made precision with raw geological power. In Peru, the iconic profile of the mountain behind Machu Picchu, known as Huayna Picchu, is visually mirrored in the architecture of the city's central plaza, creating a deliberate harmony between the built and the born. This was more than aesthetic appreciation. It suggests an intuitive understanding of geological principles, of fault lines and natural foundations. By building with the mountain, not just on it, they created structures that were inherently stable, anchored into the very bones of the planet. This holistic vision is the final and perhaps most telling piece of the puzzle. The perfect fusion of stone, the celestial alignments, and the integration with the landscape are not separate mysteries. They are all expressions of the same underlying philosophy, a worldview that saw no division between architecture, astronomy, and geology. To possess such a unified understanding of the natural world implies a breadth of knowledge that we are only now beginning to fully appreciate. It suggests that the true purpose of these sites was to create a sacred dialogue between humanity, the earth, and the stars. The stones themselves are a form of silent mathematics. Beyond their physical perfection, these ancient builders encoded a language of numbers and geometry into their work, a language we are only now beginning to decipher. Look at the foundational layout of the Giza Plateau. The positions and proportions of the pyramids are not random. They reflect a deep understanding of mathematical constants like pi and the golden ratio, concepts that form the bedrock of advanced geometry and physics. This is not about simple measurement with a knotted cord. This is about embedding fundamental truths of the universe into the very scale and orientation of a city of stone. The same sophisticated principles appear at Machu Picchu, where the relationships between structures, terraces, and plazas create a harmonious geometric pattern across the entire mountain ridge. The builders were not just placing buildings, they were composing a symphony of angles and ratios, creating spaces that feel inherently balanced and correct to the human spirit, even if we cannot immediately articulate why. This mathematical consciousness is perhaps most startlingly evident at Pumapunku. Here, the andesite blocks are not just fitted together, they are feats of geometric engineering. Each stone displays a relentless consistency with perfect 90-degree angles, uniform thickness across massive slabs, and complex, repeating notches that are identical from one block to another. To produce such standardized, precision components without the use of metal tools or powered machinery would require more than a good eye. It would demand an advanced understanding of drafting, of how to translate a three-dimensional design from a plan into a finished product made of unforgiving stone. This presents a profound historical puzzle. How could cultures that, according to our textbooks, lacked a written system for complex mathematics and had not yet formalized concepts like the number zero, achieve such a breathtaking command of geometric principles? The evidence carved in granite suggests one of two possibilities. Either we have severely underestimated the intellectual capabilities of these ancient societies, perhaps mistaking the loss of their knowledge for its absence, or this mathematical precision points to a shared, inherited science from a much older, now forgotten source of wisdom. The stones do not simply ask how they were built, but why this specific, hidden language of mathematics was so important to preserve for the ages. One of the most compelling theories suggests the stones were not cut but molded into place. This ancient chemical softening hypothesis proposes that builders possessed a lost knowledge of plant-based compounds capable of temporarily altering the physical state of granite and andesite. Imagine a thick paste or liquid derived from local flora that could be applied to the surface of a stone. This substance would not melt the rock like lava, but rather disrupt the crystalline bonds on its surface, creating a pliable, clay-like layer that could be shaped and molded before the stone returned to its original hardness. This would elegantly explain the uncanny, flowing seams and the molded appearance that defies explanation by hammerstones. Certain historical accounts and indigenous legends seem to hint at this very knowledge, speaking of liquids that could make stone soft. Modern science lends a degree of credibility to these stories. Laboratory experiments have demonstrated that organic compounds rich in oxalic acid, found in many common plants, can act as chelating agents. These agents essentially bind to the mineral components in the stone, particularly in silicates like granite, causing a superficial softening that makes the rock easier to work. For a culture with a deep, empirical understanding of their local botany, discovering and harnessing such a plant-based technology is not outside the realm of possibility. It transforms an impossible construction task into a manageable one, turning unforgiving stone into a cooperative building material. Yet for all its appeal, this theory faces significant hurdles. The most glaring is the complete absence of archaeological evidence. No residue of such a powerful chemical compound has ever been conclusively identified on the stones themselves, and no large-scale processing areas for these plants have been found near the quarries or construction sites. Furthermore, skeptics question the scalability of such a method. Could a plant-based paste truly be produced in the vast quantities needed to soften a 100-ton block, and would the effect be uniform across such a massive surface? The theory offers a beautiful and elegant solution to the mystery of the perfect fit, but until tangible proof emerges from the soil, it remains a captivating what-if, a glimpse of a technology that might have been. Sound offers a different kind of key to this ancient lock. Another captivating theory suggests that the true tool behind these marvels was not a physical object at all, but a carefully controlled application of sound. Across the globe, echoes of this idea persist in the oral traditions of the very cultures that built these sites. There are legends that speak of stones becoming weightless, levitating into place when specific chants or sacred frequencies were produced. Some accounts from ancient Egypt describe the pyramids being raised by the word of God, a phrase that some researchers interpret not as a miracle, but as a coded reference to a lost science of acoustic vibration. In South America, similar stories have been passed down for generations, telling of massive blocks that would glide across the land as if the earth itself had lost its grip, all in response to the sound of trumpets or drums. These are not merely myths, they are persistent cultural memories that point toward a common and profoundly strange technological thread. The concept finds a surprising foothold in modern physics. We know that everything, including solid stone, has a natural resonant frequency. When this frequency is matched and amplified, the effects can be dramatic. In laboratory settings, scientists have observed that high-intensity sound waves can create standing waves that appear to reduce the effects of gravity on small objects, a phenomenon known as acoustic levitation. Other experiments show that specific frequencies can temporarily alter the friction between two surfaces, or even cause certain brittle materials to fluidize and behave like a liquid. Imagine the potential application on a construction site. If a massive stone block could be made to resonate at just the right frequency, its immense weight might become manageable, allowing it to be guided into position with minimal physical force. The precise fitting of the stones could have been achieved by using sound to vibrate two blocks simultaneously, causing their surfaces to mesh together with liquid-like perfection as they settled into their shared resonant state. This would elegantly explain the absence of tool marks and the seemingly molded appearance of the joints. Of course, this theory ventures into highly speculative territory. The energy required to achieve such effects on a 100-ton block of granite is almost unimaginable with any technology we would recognize. There is no archaeological evidence, no ancient sonic device yet unearthed, that could have generated such powerful and focused acoustics. The theory remains a beautiful and haunting possibility, a whisper from the past that challenges our understanding of physics and suggests that the true tools used to build these wonders might have been invisible, leaving only their impossible results for us to ponder. A third and even more controversial theory suggests that the stone was shaped by fire. On certain blocks at Sacsayhuamán, close inspection reveals surfaces with a strange, almost glassy sheen, as if the rock had been briefly licked by an impossibly hot flame. This subtle vitrification, a telltale sign of extreme thermal shock, hints that the builders may have commanded temperatures high enough to fundamentally alter the stone's surface. The concept is startlingly simple yet profound. Imagine directing a narrow, concentrated beam of heat along the edge of a granite block. The intense energy would not melt the stone into a puddle, but it could cause the outermost crystalline structure to expand and become temporarily plastic, allowing it to be molded or pressed against its neighbor. When the heat was removed, the stone would cool and harden again, locking the two pieces into a single, fused unit. This would elegantly explain the flowing, seamless joints and the complete absence of tool marks, as the final shaping was done not by impact, but by a controlled application of energy. The question, of course, is how such a technology could have existed. Modern industry uses lasers for precision cutting and welding, achieving effects that look eerily similar to what we see on these ancient stones. Could the builders have found a way to concentrate sunlight, perhaps using vast arrays of polished mirrors to focus the sun's rays into a pinpoint of devastating heat? Or did they master a chemical process, combining specific minerals to create a thermite-like reaction that generated the necessary temperatures? While no such devices have been unearthed, the stone itself seems to bear the thermal fingerprints of a process we cannot yet fully explain. This theory pushes the boundaries of conventional history, forcing us to consider that the path of ancient innovation may have branched in directions we are only beginning to suspect. The most controversial idea whispers of a forgotten world, a chapter of human history that was lost long before our own began. This theory proposes that the master builders were not the cultures we credit today, but a far older, advanced civilization whose name and story have been erased by time. Those who support this view look at the impossible precision and ask a simple, haunting question. How could societies we consider ancient, like the Inca or the pre-dynastic Egyptians, have achieved such a flawless standard right from the very start of their building projects? They see a technology that seems to appear fully formed, without any visible period of trial and error or gradual development in the archaeological record. The similarities between sites separated by oceans are seen not as parallel evolution, but as the scattered fingerprints of a single, global parent culture. This shared knowledge, it is suggested, was then fragmented and lost in the aftermath of a planet-altering event, a great cataclysm that reset the course of human history. The appeal of this narrative is powerful, offering a unified answer to a global mystery and speaking to a deep-seated human curiosity about lost golden ages. Yet, this grand hypothesis stands on fragile ground. Mainstream archaeology points to a clear and continuous cultural footprint at places like Machu Picchu and the Giza Plateau. The artifacts, the art, the very way of life found there are undeniably linked to the known cultures of the Inca and Old Kingdom Egypt. To insert an unknown, hyper-advanced society into this timeline creates more questions than it answers. Where is the evidence of their daily lives? Where are their cities, their tools, their refuse? A civilization capable of such works would have left an immense and unmistakable archaeological trail, one that simply has not been found. So we are left at a crossroads, balancing the sheer wonder of the stones against the rigorous demands of evidence. Perhaps the truth does not require a lost super-civilization, but rather a profound re-evaluation of the incredible ingenuity inherent in our own ancestors, and the sobering realization that knowledge, even of the most advanced kind, can indeed vanish from the world. Modern science has become our time machine, offering a silent conversation with the past through tools that see what the naked eye cannot. Ground-penetrating radar sends pulses deep into the earth, mapping hidden chambers and foundational voids without moving a single stone. Three-dimensional laser scanning captures the precise geometry of every wall with sub-millimeter accuracy, creating a digital twin of these ancient sites. This data reveals patterns of stress and wear, showing us exactly how the structures have settled and shifted over centuries. It is like having the builder's original blueprint, written not on paper but in the very contours of the stone itself. The most telling clues, however, are often the smallest. Microscopic analysis of the stone surfaces can detect the faintest traces of tool marks, grooves so minute they feel like nothing more than a variation in the stone's natural texture. These microscopic signatures can tell us the direction of a cut, the type of abrasive used, and even the amount of force applied. In some cases, this high-resolution scrutiny has revealed surfaces that are unnaturally smooth, lacking the crystalline fractures you would expect from percussive tools. This absence of evidence is itself a powerful form of data, quietly ruling out certain methods and pointing toward others. Perhaps the most tantalizing application is chemical residue analysis. Scientists can now take minute samples from the seams between stones and test for the presence of organic compounds. The discovery of oxalic acid or other plant-based chemicals in these critical joints would be a monumental step toward validating the stone softening theory. It would transform a compelling legend into a documented historical practice. These scientific approaches do not seek to replace the wonder, but to deepen it. They are building a new foundation of fact, brick by evidentiary brick, allowing us to move beyond pure speculation and into a more informed understanding of one of history's greatest architectural achievements. The proof of any theory lies in the attempt to rebuild it with your own hands. Across the globe, a quiet revolution is taking place not in lecture halls, but in quarries and workshops where experimental archaeologists are trying to turn back time. Their mission is simple yet profound: to recreate the ancient stonework using only the tools and materials that would have been available thousands of years ago. They carve with stone hammers, grind with sand and water, and haul massive blocks with ropes and log rollers. The results of these painstaking projects are both illuminating and deeply humbling. With immense patience and generations of forgotten skill, it is possible to achieve remarkably close fits between large stones. Teams have demonstrated that dragging a multi-ton block on a prepared causeway of logs is a feasible, if brutally difficult, undertaking. These experiments restore a vital human element to the mystery, showing us the incredible power of coordinated labor and practiced technique. Yet for every success, these reenactments also reveal a stark and telling gap. The precision achieved, while impressive, often falls just short of the ancient standard. The seams are good, but they are not perfect. The surfaces are smooth, but they lack that flowing, fused quality. The process of shaping the hardest granite with nothing but another rock is agonizingly slow, raising serious questions about the timeline of massive projects. Most tellingly, the methods that work reasonably well on softer limestone often fail completely when applied to the andesite and granite used at the most mysterious sites. This gap between what we can replicate and what was actually built is not a failure of modern effort, but a crucial clue. It tells us that the conventional toolbox we have credited to the ancients might be incomplete. The experiments do not close the case, they open a new one, suggesting that a final, crucial piece of technology, a secret ingredient or a lost process, still eludes our understanding. Perhaps the most overlooked library in this mystery is not made of stone, but of stories. The descendants of the original builders have preserved oral traditions for countless generations, narratives rich with symbolic meaning that modern science is only beginning to translate. These are not simple fairy tales, but complex cultural memories, where practical knowledge is often wrapped in the language of myth and ritual. In the high Andes, elders speak of a time when the very stones lost their hardness, becoming pliable through the application of juices from specific, locally sourced plants. To an outsider, this sounds like pure legend, a magical explanation for an impossible feat. But when viewed through a different lens, these stories read like precise technical manuals, using the available vocabulary of their time to describe a sophisticated botanical technology. Similarly, ancient texts from Southeast Asia detail elaborate ceremonies that had to be performed before the placement of a cornerstone. The rhythms of specific drums and the chanting of certain tones were considered essential to the building process, not just for spiritual blessing, but as an active part of the construction itself. For a long time, Western archaeology dismissed these accounts as purely religious or symbolic, missing the potential practical instructions embedded within them. Now a profound shift is occurring. Researchers are increasingly sitting with indigenous knowledge keepers, not as subjects to be studied, but as partners in a shared investigation. This collaborative approach is revealing a more nuanced picture. A story about a bird teaching people to build might actually encode the principle of using lightweight, triangular supports during construction. A myth about a giant who carried stones could be a metaphorical way of describing the use of counterweights and levers. By learning the cultural context and the deeper meaning behind the symbols, scientists are gaining access to a completely different category of evidence. This partnership is proving that the answer to how these stones were fused may not lie in a single, lost tool, but in a forgotten way of seeing the world, one where science, spirit, and nature were deeply intertwined. The fortress of Sacsayhuamán stands as a monumental puzzle just above the ancient Inca capital of Cusco. Its zigzagging walls, composed of colossal limestone blocks, create a defensive structure that is both imposing and architecturally baffling. Each of these giant stones, some tipping the scales at well over 100 tons, is a unique geometric masterpiece. They are not simple rectangles, but complex polygonal shapes with as many as 12 distinct angles and facets. Yet, against all odds, each one locks perfectly into its neighbors, creating a wall without mortar that has survived devastating earthquakes for centuries. The precision is so absolute that the entire structure moves as a single, resilient unit when the ground shakes, a feat modern engineering still struggles to replicate with such elemental materials. How could such perfection be achieved in a mere 50 years, a blink in time for a project of this scale? The conventional explanation of stone hammers and bronze chisels feels insufficient when confronted with the evidence. The sheer logistics are staggering, from quarrying these behemoths to transporting them across rugged terrain, and then executing this three-dimensional stone puzzle with zero margin for error. The joints are so meticulously crafted that they exclude not just mortar, but even the thinnest blade. This was not a slow, evolutionary process of trial and error. It was a sudden, explosive manifestation of a fully realized and supremely confident building technology. The site does not ask us to admire patient labor, but to recognize a lost science, one that understood stone in a way we are only beginning to comprehend. Pumapunku is not merely a collection of ruins, it is a collection of engineering problems carved in stone. Nestled in the high plains of Bolivia, this site dismantles every conventional assumption about ancient construction. The material alone presents the first great hurdle, andesite. This is a volcanic rock of immense hardness, a substance that would quickly dull modern steel tools. Yet here it has been shaped into forms of breathtaking geometric purity. We are not looking at roughly hewn blocks, but at what appear to be prefabricated components. Slabs with edges as straight as a ruler stretch for many feet, meeting at perfect 90-degree corners. Other stones are carved with intricate, repeating patterns, H-shaped slots and symmetrical notches that are identical from one block to another. This is not the organic irregularity of hand-fitted polygonal masonry. This is the relentless, standardized precision of mass production. To achieve this with stone hammers and copper chisels seems almost unthinkable. The surfaces are flat and smooth, lacking the telltale undulations and impact marks of percussive shaping. It is as if the stone was simply persuaded to take this form, rather than being forced. The most baffling elements are the complex interlocking channels and recesses carved deep into the faces of these massive slabs. These are not simple decorative grooves. They look like the connection points for a larger, assembled structure, the kind of precision engineering you would expect in a modern machine shop. Creating these features with primitive tools would require a level of control and measurement that challenges our entire timeline of technological development. The site's age only deepens the mystery, with some estimates placing its origins far earlier than the cultures traditionally credited with its construction. This leaves us with a profound question. What kind of society possessed the knowledge to work stone with such machined perfection? And why does their story seem to have vanished so completely from the historical record? Deep within the Cambodian jungle, the temples of Angkor present a different kind of stone riddle. Here, the primary material is laterite, a porous, iron-rich stone that hardens upon exposure to air. The builders of Angkor fitted massive blocks of this material together without a trace of mortar, creating sprawling temple mountains that have endured for centuries. The precision here is less about the complex jigsaw-like polygons of Peru and more about a relentless, grid-like perfection across immense, flat surfaces. Walking through the galleries of Angkor Wat or the terraces of the Bayon, you are surrounded by walls where the seams between stones are so fine they are often invisible from just a few steps away. This consistency is staggering when you consider the sheer scale, with construction spanning hundreds of years and multiple royal dynasties. The quality control never wavered, suggesting a deeply ingrained and perfectly preserved building tradition passed meticulously from one generation of artisans to the next. What makes Angkor uniquely compelling is the mixed evidence left behind. In some areas, you can find quarries with laterite blocks showing the clear, parallel grooves of metal chisels, a testament to the skilled use of conventional tools. Yet in other, more refined sections of the very same temples, the stonework tells a different story. The joints are so intricate and flawlessly meshed that they lack the tiny, telltale imperfections of hand carving. Some surfaces, particularly on the most precisely fitted blocks, have a subtle, almost flowing texture, as if the laterite was smoothed into its final state rather than chiseled. This duality is the core of the mystery at Angkor. It suggests that the builders possessed a full spectrum of techniques, from the conventional to the highly advanced, and they applied the most sophisticated methods to the most critical, load-bearing or sacred parts of their constructions. The endurance of these structures, standing firm in a climate known for its destructive monsoon rains and relentless vegetation, speaks to the success of their choices. The longevity of Angkor forces us to ask, was their most guarded secret not a single tool, but a complete and layered system of construction, one that we are only just beginning to perceive? Far out in the vast expanse of the Pacific Ocean, the stone platforms of Easter Island stand as a powerful testament to this global riddle. The Ahu, the long ceremonial platforms that cradle the famous Moai statues, are built from massive basalt blocks. These stones are not simply stacked, they are intricately shaped and interlocked with a precision that feels completely at odds with the island's extreme isolation. Here, surrounded by thousands of miles of open sea, a community with no apparent contact with the outside world achieved a level of stonemasonry that echoes the mastery found in the high Andes and the Cambodian jungle. The basalt blocks are fitted together with such care that the joints are nearly invisible, creating a foundation of immense stability meant to endure for the ages. This was not a crude effort by a people merely surviving. It was the work of a sophisticated society that poured its collective skill into creating eternal monuments. The question this raises is profound. How did a population on one of the most remote islands on the planet, with limited access to timber and other resources, independently develop such advanced technical knowledge? Their isolation makes the parallel development all the more startling. It suggests that the drive to achieve perfect stone fusion and the intellectual capacity to solve the engineering challenges involved may be a deeper, more universal facet of human ingenuity than we ever realized. The people of Rapa Nui were not copying anyone. They were discovering the same profound architectural truths on their own, answering a silent call to build in harmony with the stone itself. Their achievement forces us to reconsider the very seeds of innovation, proving that profound knowledge can spring up in the most unexpected places, completely rewriting the map of ancient human potential. Deep in the remote Siberian mountains, a different kind of stone mystery lies almost completely hidden from the world. At Gornaya, Shoria, the scale of the achievement defies not just explanation, but belief itself. Here, colossal stone blocks, some estimated to weigh over 3,000 tons, are stacked into formations that echo the finest polygonal masonry of Peru. To put that weight into perspective, a single one of these stones is heavier than two fully loaded Boeing 747 jumbo jets. The precision with which these behemoths are joined is what truly stuns the observer. Despite their unimaginable mass, the seams between them are tight and complex, fitting together with a care that suggests the builders were working with delicate tiles, not the largest cut stones ever discovered on the planet. This creates a paradox that is almost physical in its intensity, a clash between the raw, brutal power required to move such masses and the feather-light touch needed to achieve such a perfect fit. How does a culture move a small mountain and then treat its surface with the precision of a master jeweler? The site offers no easy answers, primarily because it lacks any clear cultural attribution. This region of Siberia is not known for a civilization that produced such sophisticated stonework in its recorded history. There are no companion temples, no surrounding cities, no pottery shards or traditional tools that point to a known people. The stones stand alone, a silent, monumental question mark carved into the mountainside. This isolation deepens the mystery, severing it from the familiar narratives we use to explain other ancient sites. Without a cultural context, we are left only with the physical evidence, and that evidence speaks of challenges that seem insurmountable. The terrain itself is a formidable obstacle course of dense taiga forest and rugged, uneven ground. Transporting a 3,000-ton block through such a landscape using only rollers, ramps, and human labor feels less like a difficult engineering project and more like an outright impossibility. The logistics of simply feeding and housing a workforce large enough to pull such a stone would have left an immense archaeological footprint, one that has not been found. This forces a profound question: were the builders of Gornaya Shoria using a method of movement and construction so advanced that it left almost no trace beyond the stones themselves? As one of the least understood examples of this global phenomenon, Gornaya Shoria does not just ask how it was built, it quietly asks if we have been looking at the entire story of our ancient past through a lens that is far too small. Our modern world holds its own keys to this ancient lock. We can now achieve that same breathtaking precision with technologies that feel almost like magic. Computer-controlled diamond saws slice through granite as if it were soft wood, guided by digital blueprints to create edges with microscopic perfection. Laser cutters use focused light to carve intricate shapes with a clean, almost surgical accuracy. Even water, when pressurized to an extreme degree and mixed with abrasive particles, becomes a water jet cutter capable of slicing through foot-thick stone slabs with a seam as fine as a human hair. These are the tools that allow us to replicate the flawless joints found at sites like Pumapunku. But the parallels do not end with cutting. Modern industry also uses intense heat to shape hard materials. Plasma torches, which generate a stream of superheated ionized gas, can melt and reshape the surface of stone, creating that same flowing, fused appearance we see on ancient blocks. Researchers have even experimented with using vast arrays of mirrors to concentrate sunlight, achieving temperatures high enough to soften granite. This thermal approach offers a compelling modern analogy for the strange, vitrified surfaces found on some ancient stones. Then there is the chemistry. Today, we have chemical treatments that can be applied to stone surfaces to make them temporarily softer and more malleable for working, before they re-harden to their original strength. The existence of these advanced methods does not prove that ancient cultures had them, but it powerfully reframes the entire mystery. It demonstrates that the physical results we see in the ancient world are achievable through multiple pathways, not just one. Knowing what is possible with a sophisticated toolkit forces us to look at the ancient achievements with fresh eyes. If we can use concentrated sunlight to soften stone, is it so hard to believe they discovered a way to focus the sun's power with polished metal or mineral lenses? If we can develop chemical softeners, is it unreasonable to think that generations of careful observation could have revealed plant-based compounds with similar properties? The gap between their results and our own begins to look less like an impossible chasm and more like a difference in the specific tools rather than the underlying intelligence. This shifts the question from a simple "how did they do it" to a much deeper inquiry. What shared human problem were they solving, and what unique branch of physics or chemistry did they cultivate to solve it? Our modern methods show us that the stone itself is willing to cooperate if you only know how to ask. The very stone they chose tells a silent story of intent and capability. When we look at the tools a civilization used, we must first look at the material they were determined to master. The choice to build with granite, andesite, or basalt is a declaration in itself. These are not just rocks, they are among the hardest materials on our planet, with a crystalline structure that laughs at soft copper chisels and resists the pounding of stone hammers. To shape them with simple force would be a battle of attrition, a project of countless lifetimes. Yet, these are precisely the stones we find at the heart of the most precise and mysterious sites around the world. At Pumapunku, it is andesite, a volcanic rock of immense durability. At the Giza Plateau, the inner chambers are lined with granite. Easter Island's platforms are built from unyielding basalt. This is not a coincidence. It suggests that the builders were not merely using the most convenient material available. They were deliberately selecting the most permanent, the most challenging, and ultimately the most revealing. If your goal is to create a structure that will stand for millennia, you choose granite. If your methods are advanced enough to handle it, then its difficulty becomes a testament to your skill. The stone itself becomes part of the message. Softer stones like limestone and sandstone tell a different, equally important part of the story. These materials are more cooperative. You can see the evidence of conventional tools on their surfaces, the clear marks of metal chisels and the grooves of abrasive sands. Quarries for these stones are often littered with the debris of this more understandable, if still impressive, process. This creates a fascinating duality in the ancient world. In many sites, you will find both types of masonry. There will be walls of rougher, cut limestone, and then, for the most critical foundations or the most sacred spaces, a sudden shift to perfectly fitted granite or andesite blocks that seem to belong to a different era of technology altogether. This is not a contradiction, it is a clue. It suggests that the builders possessed a full spectrum of knowledge. They had everyday methods for everyday stone, and they had reserved highly advanced techniques for the most demanding and important architectural challenges. The harder stones were not just a brute force problem to be solved, they were a canvas for a different kind of science. The crystalline heart of a stone like granite holds the key to why some theories feel so compelling. Granite is an igneous rock, a mosaic of interlocking mineral crystals like quartz and feldspar. This structure gives it great strength, but it also presents a potential vulnerability. When subjected to intense, focused heat, these different minerals expand at different rates. This can create microscopic stresses, causing the surface to become more pliable, almost like a stiff putty. A chemical agent, perhaps derived from a specific plant, could theoretically work by targeting the bonds between these crystals, temporarily loosening their grip on one another. This would not melt the rock, but it could create a softened, workable skin on its surface. The properties of the stone, therefore, are not just an obstacle, they are a set of instructions. A deep understanding of geology would reveal which stones were most susceptible to thermal shock and which might react to certain organic compounds. This turns the mystery from a question of force into a question of knowledge. Did these ancient builders possess an empirical, almost alchemical understanding of their materials? Did they know that andesite, when heated in a specific way, could be molded, or that a particular vine's sap could make granite temporarily soft? The geological context is not a passive backdrop. It is an active participant in the mystery, pointing toward methods that worked with the stone's inherent properties rather than simply battling against them. A 50-year construction window for a site like Sacsayhuamán sounds generous until you confront the reality of the stone. Each of those colossal, multi-angled blocks represents a unique geometric challenge that had to be quarried, transported, shaped, and fitted with zero margin for error. To achieve this with only stone hammers and abrasives would require an almost unimaginable cycle of trial and error. Imagine the process for a single 100-ton block. It is maneuvered into place, a mason checks the fit, identifies a high spot, and then an army of workers must somehow lift the block again to grind that tiny imperfection away. This cycle would repeat dozens, perhaps hundreds of times for just one stone. When you multiply that by the thousands of blocks in a single complex, the math of time begins to collapse. The sheer logistics would stretch a 50-year project into centuries, yet the archaeological record does not show this kind of prolonged, multi-generational effort. Instead, the evidence points to concentrated bursts of construction, as if these monumental puzzles were solved with a decisive speed that defies the traditional narrative. This forces a critical question: could the methods we have credited for so long actually accomplish such a feat within the time we now believe they had? The answer seems to be a quiet but firm no. A shorter timeline does not simply mean more people working faster. It demands a completely different approach to the stone itself. The conventional model of pounding and grinding is inherently profoundly slow. If the clock was ticking faster than we thought, then the tools must have been smarter. This is where the mystery deepens from a question of patience into a question of technology. What faster, more efficient process could have allowed them to achieve in a decade what should have taken 100 years? Perhaps the stone was not carved at all, but was persuaded into its perfect shape, turning a lifetime of labor into a single, masterful act. The masterful fit of these stones was not born from engineering ambition alone, but from a profound and sacred dialogue with the world. To see these structures as only monuments is to miss their true voice. For the cultures that raised them, stone was not an inert material waiting to be conquered. It was a living, breathing part of the cosmos. Granite and andesite were believed to hold a spirit, a consciousness that demanded respect and collaboration. This worldview transforms the entire construction process from a technical challenge into a ceremonial act. The shaping of a block was not a matter of brute force, but a careful negotiation, a request made to the stone itself to take on a new form. This explains why the most perfect joints are often found in the most spiritually significant parts of a temple or fortress. The flawless fusion was not just for stability, it was a symbolic act of unity, a way to create a seamless boundary between the human realm and the divine. The rituals we might dismiss as superstition, the chants and offerings performed before a stone was set, were likely integral to the technical process. They were the method of aligning the will of the builder with the spirit of the material, creating a harmony that resulted in physical perfection. When a culture believes the earth is alive, every action taken upon it is infused with meaning. The choice to build with the most permanent stone was a statement of eternity, a desire to create a sacred space that would endure as long as the mountains themselves. The incredible effort expended, the generations of labor, make perfect sense when you understand that they were not just building walls, they were weaving the physical and spiritual worlds together. The perfection we struggle to explain was for them the only acceptable outcome, a necessary signature of a covenant between humanity, the earth, and the stars. This enduring strength is a silent testament to a forgotten science of survival. While modern buildings might last a century or two before requiring significant repair, these ancient walls have shrugged off millennia of earthquakes, torrential rains, and relentless winds. Their longevity is not a happy accident, it is the direct result of a brilliant and intentional design. The perfect, interlocking fit of the stones is the key. A wall made of uniform, rectangular blocks is rigid like a single sheet of glass. When an earthquake hits, that wall has no choice but to absorb the full force of the shock, and it will crack. But a wall built from a chaotic jigsaw of polygonal stones is completely different. Each irregular block, locked tightly into its neighbors, acts as an individual shock absorber. When the ground shakes, the energy is not concentrated in one place. Instead, it travels through the wall along a complex web of interlocking angles, being dissipated and redirected at every turn. The entire structure moves as a single, flexible unit, dancing with the tremor instead of fighting it. This principle of distributed stress is something modern engineers strive to achieve with complex materials and computer models. Yet here it is, perfected in stone, by civilizations we are only beginning to understand. The builders did not just assemble walls, they engineered resilient, living systems. Their choice of location reveals another layer of this profound wisdom. These structures are rarely found on unstable ground. They are anchored directly to the most stable foundation available, the living bedrock of the mountain itself. At Machu Picchu, the buildings are not simply placed on the ridge, they are fused with it. The foundational stones are often the natural, contoured rock of the mountain, shaped and incorporated directly into the design. This provided an unshakable base that moved in unison with the Earth during seismic events. Furthermore, many sites are strategically positioned in natural alcoves or on plateaus that are shielded from the worst of the elements, avoiding direct lines of wind erosion or flood paths. This deliberate siting speaks to an intimate, generations-deep knowledge of the local geography, geology, and climate patterns. They were not conquering the landscape, they were collaborating with it, using its inherent strengths to protect their creations. The fact that these structures stand today, long after the cultures that built them have transformed, forces a humbling question. Did these ancient builders possess an intuitive grasp of physics and material science that we, with all our technology, are only now formally rediscovering through advanced simulation? Their legacy is not just in the stones they left behind, but in the timeless principles of resilience they encoded within them, a masterclass in building for eternity. These silent stones are now meeting the most advanced listeners of our time. To solve a puzzle this ancient, we cannot rely on a single field of expertise. The true breakthrough is happening where disciplines collide, where the archaeologist's trowel meets the materials scientist's electron microscope. Each field offers a different lens, and when these views are combined, a far richer picture begins to emerge. Archaeology provides the essential foundation of cultural context. It tells us who lived here, what they left behind, and how their society was organized. This traditional detective work establishes the timeline and the human story surrounding the stones. But to understand the stones themselves, we need a different kind of vision. This is where materials science enters the conversation. Using powerful scanning electron microscopes, scientists can examine the surface of a granite block at a magnification of thousands of times. They are not just looking for obvious tool marks, but for subtler clues, for evidence of thermal alteration or chemical residues that might hint at a softening agent. A single, minuscule trace of an organic compound trapped in a seam could rewrite our entire understanding of their methods. Meanwhile, structural engineers bring their own crucial perspective. They create sophisticated computer models to simulate how these polygonal walls behave during an earthquake. By analyzing the distribution of stress and strain, they can quantify the sheer brilliance of the design, showing us exactly why these chaotic-looking walls are so incredibly resilient. Finally, the geologist completes the team. By identifying the exact quarry source of the stones, they can reveal the immense logistical challenges the builders faced. More importantly, they can analyze the mineral composition of the rock, helping to determine which methods, whether thermal, chemical, or acoustic, would have been most effective on that specific type of stone. This collaborative effort is slowly but surely dismantling the old, simplistic narratives. It is no longer about a lone archaeologist with a theory, but a coordinated team with hard data. The mystery of the fused stones is no longer a historical curiosity. It is a scientific frontier where every new discovery brings us closer to hearing the whispers of a lost technology. The search for lost tools carries a responsibility as profound as the mystery itself. As we seek to understand how these stones were fused, we must also ask a deeper question: for whom are we seeking these answers? Scientific curiosity is a powerful engine for discovery, but it must be guided by a deep respect for the living cultures who are the direct descendants of these master builders. At many of these sites, the stones are not merely relics of a forgotten past. They are active parts of a sacred landscape, woven into the spiritual identity of communities today. An archaeological team arriving with ground-penetrating radar and laser scanners is not just conducting research, they are entering a space of profound cultural meaning. The most responsible path forward is one built on genuine partnership. This means moving beyond simply obtaining permits from government bodies and toward building lasting relationships with indigenous elders and knowledge keepers. It involves listening as much as speaking, learning the cultural protocols that govern these places, and recognizing that traditional stories are not myths but a different form of data, rich with encoded wisdom. A collaborative approach transforms the quest from an extraction of secrets into a shared journey of rediscovery, where modern science and ancestral memory can illuminate each other. This ethical framework also forces us to reconsider our methods. The desire to test a theory by attempting to soften a small, out-of-the-way piece of granite at an ancient site might seem scientifically valid, but it risks permanently damaging an irreplaceable heritage. Is proving a hypothesis worth leaving a modern scar on a stone that has stood untouched for 1,000 years? the principle of minimal intervention must be our guide, favoring non-destructive analysis that reads the stone without altering it. Similarly, we must guard against the arrogance of our own technological lens, assuming that ancient builders were simply primitive versions of ourselves, striving toward our modern industrial goals, can blind us to the true nature of their achievements. Their goals may have been entirely different, blending the practical with the spiritual in ways we are only beginning to appreciate. The ultimate challenge is not just to uncover how they moved a mountain, but to understand why they chose to do so and to honor that sacred purpose in our pursuit of knowledge. This ethical dimension does not hinder the investigation. It enriches it, ensuring that the answers we find do not come at the cost of the legacy we seek to preserve. The next wave of discovery will not come from a larger excavation, but from a deeper look. Emerging technologies are giving us the ability to see straight through solid stone, revealing secrets that have been hidden for thousands of years. Imagine using a scanner that reads the stone like a medical X-ray reads the human body. Advanced imaging techniques such as multispectral scanning and terahertz imaging do exactly that. They can detect subtle variations in density and composition beneath the surface, mapping out hidden chambers, internal fractures, or even the ghostly outlines of ancient tool marks that have been completely erased from the exterior. This is like discovering the builder's hidden notes written not on paper, but within the very fabric of the stone itself. We might finally see the internal structure of those impossibly tight joints, understanding if they were carved, molded, or fused from within. Beyond seeing, we are also learning to think across continents at a speed no human researcher could ever match. Artificial intelligence is now being trained to analyze the geometric patterns from sites as far apart as Peru, Cambodia, and Egypt. An AI can process millions of data points, comparing the angles of blocks, the curvature of seams, and the distribution of stress points. Its objective eye might identify a common design principle or a shared construction signature that has eluded us simply because the scale was too vast for any single mind to correlate. It could answer the haunting question of whether this was parallel genius or a shared inheritance by finding the subtle fingerprints of a single school of thought encoded in stone across the globe. The most immediate breakthroughs, however, are happening right at the site, in the hands of researchers equipped with portable labs. Sophisticated chemical analysis equipment that once required a sample to be sent to a distant university can now be brought directly to the remote jungle or mountain peak. A scientist can place a handheld device against the seam between two stones and, without scratching the surface, perform a non-destructive test that detects the faintest chemical residues. The dream of finding evidence for a plant-based softening agent no longer requires damaging the monument. We can now search for those answers with the lightest of touches, preserving the past while uncovering its truths. These are not the tools of science fiction, they are the rapidly evolving instruments of modern archaeology. As they become more accessible and powerful, they promise to transform our speculation into evidence. The future of this investigation is one of silent, penetrating vision, where the stones themselves will finally begin to speak their long-held secrets. These silent stones question the very timeline of human achievement. Our modern story of history is often a straight line, beginning with simple tools and steadily climbing toward greater complexity. We imagine progress as an inevitable march forward, but the evidence of these walls tells a different, more complex tale. If ancient builders truly commanded methods that allowed them to soften granite or move mountains with sound, then our linear narrative shatters. It would mean that profound technological peaks have been reached, lost, and then forgotten, long before our own industrial age began. This is not about finding evidence of alien visitors or lost super civilizations, but about recognizing the staggering depths of ingenuity inherent within humanity itself. It forces us to ask a humbling question: how many times has human knowledge had to reinvent itself after a period of forgetting? The implications ripple far beyond archaeology. Consider our modern approach to construction, a process often reliant on immense energy consumption, heavy machinery, and materials that can degrade within a century. The ancient methods, by contrast, seem to have achieved a remarkable harmony with the environment. They used local stone, and if the theories are correct, they may have employed plant-based chemistry or fundamental physics rather than fossil fuels. Their results were structures that have endured for thousands of years with minimal environmental impact. Understanding their techniques could unlock principles for sustainable building that are both incredibly resilient and deeply attuned to the natural world. We might learn how to build with the land, not just on it, creating shelters that are as permanent as the landscapes they inhabit. Ultimately, these mysteries matter because they challenge our most basic assumptions about human potential. They suggest that the capacity for advanced problem-solving is not a modern invention, but a constant thread in the human story. The drive to understand the world and reshape it with elegance and precision is a timeless quality. By listening to the quiet message of these perfectly fused stones, we are not just uncovering a lost technology, we are rediscovering a forgotten dimension of our own capabilities. The true lesson may be that our ancestors were not primitive versions of ourselves, but masters of a different kind of science, one whose echoes we are only now learning to hear. Our journey through these ancient mysteries reveals a world far more complex than our textbooks once described. We have walked among stones that appear to have been softened like clay in Peru and stood before the machined perfection of temples in Bolivia, each site whispering of a forgotten chapter in human ingenuity. These are not mere monuments, they are challenges carved in granite, silently questioning the limits we place on the past. While the full story of how these wonders were built remains just beyond our grasp, the search itself is transforming our understanding. Every new scan of the stone, every partnership with indigenous knowledge keepers, and every experimental reconstruction brings a fresh piece of the puzzle into view. What becomes undeniably clear is that ancient builders possessed a profound and sophisticated knowledge of their world, a fusion of art, science, and spirit that we are only beginning to decode. The investigation is far from over, and each discovery reminds us that history is not a closed book, but a living narrative, always ready to surprise us with its depth and complexity. I would love to hear your own thoughts on these enduring mysteries, so feel free to share your perspectives and theories in the comments.